Alright guys, here is the review worksheet packet that I want to go over a few questions with you. I'll try to give you hints. I will not be able to solve every single question here in this worksheet, but I want to guide you through it as much as I can. So let's start. So when I see question number 1 through 10 says write the equation that represents the given graph. Okay, so we are writing equations for each of these graphs. It's working backwards with all the steps that we've been doing to graph functions. Now we need to work backwards. There are two of them. The first, number 1 and 2, they are, it's almost like sight words in kindergarten and in grade. There's things that you have to know, like sight words. You have to memorize it. And these two graphs is one of those that you just have to know what they come from, okay, where they come from and what they look like. So whenever we have f of x equals a constant, y equals a constant, that is a horizontal graph, and that's exactly what you have here. So this is the graph of a y equals a certain constant. I'm pretty sure if you count 1, 2, you will know what that constant is. Okay, so that's kind of like one of those memorized graphs. And then this is exactly the same case, but this is the x equals a constant. So vertical ones are x equals, horizontal ones are y equals constants. Okay, I'm pretty sure you can count here to negative, this is -1, -2, -3. Okay, so the answer here would be x equals -3, and here would be y equals +2. Okay, or f of x equals 2. So those are the two very, very classical graphs in algebra. All right, so let's take a look at the ones that takes a little bit more time. This one over here, we look at it, we see is a line. It's a linear function. Immediately, the first thing that comes to my mind is y equals mx plus b. B is the y-intercept, and m is the slope. Oh, not slope, slope. All right, so you should be able to see your y-intercept of -1, and you should be able to count and get to the next point, count your slope. Okay, so go ahead and count to rise 1, run 2, that's your slope and your y-intercept. Here is where I want to spend a little bit more time, is on parabolas. I would do example number 4, and with that same idea, you'll be able to do example number 5 and 6. Okay, 5 and 6, you'll be able to do it. So when I look at parabola, I immediately think, what is the equation of a parabola? And I gave you a little worksheet that shows the equation for each one of them. Y equals, there's a stretch, A, quantity, x minus h squared plus k. Okay, there's two options, the plus k on this side, or subtract it and you have the k on this side. Whatever way you want to use it. I have such a habit of always keeping the k on this side. I use it all year long on this side. But I'm okay if you use it on the other side, does not matter. Alright, so h and k is our vertex. So immediately I see right here, there's my vertex, 0, 0. Okay, 0 for x, 0 for y. That's my h, that's my k. So that is an easy point to plug in. So we simplify our equation immediately. Y equals A, quantity, x minus 0 is just x squared, and there's no reason to add a 0 here. Okay, so there you go. My equation is almost done. I could almost give this answer, but I cannot leave the A undefined. We have to know what this A is. And there's why they always make another very, very obvious point on the graph. X equals 1, y equals 2. I will use this other point to plug it in here carefully and solve it for A. So I am going to go ahead and plug 2 for y. I'm trying to solve for A, and 1 equals the x value right there. Okay, so 1 squared is 1, and 1 times A, it will just be A. A equals 2. Now I have everything I need. I have my h and k, I have the A equals 2. Now I can go ahead and come over here and write the equation. Y equals 2, that has to exist, quantity, x minus a 0. You can write minus a 0, or you can leave it alone. There's not a need for it. Minus a 0 square plus a 0, you also don't need to write. So pretty much that is the equation for this graph. Okay, so notice my steps over here. I wrote the general form of the equation for a parabola. I plugged in my h and k, and then I solve for my a using this extra point that there's always on the graph. Okay, so if you come over here to question number 5, you will see that there is a vertex, negative 2, 0. I would definitely plug that in for h and k. And then there's this extra point, 0, negative 2, for my extra points to solve for a. Okay? In all of the parabolas, you'll be able to determine what the x and the y is for h, k for the vertex. And you'll be able to use another point, 0, 5, to solve for a. Okay? So that is just the steps you need to do. All right? Now let's go ahead and move on to absolute values. Absolute values functions has this form right here. Y equals the slope. It's called linear absolute values. Just like a line, there's a slope. So y equals the slope m times the absolute value of x minus h plus k. Just like a parabola, we have this little starting point right here, right there, which is 3, negative 2. And I can just count the slope. How do I get from this point A, to point B over here? You just count the slope. Rise 1, 2, so rise 2, and run 1, 2, 3, and run 3. So I can identify the slope, and I can identify the h and k. The h and k here is 3, negative 2. So I can go ahead and plug everything in here, and there's no calculation needed at all. So my function would look like, with all the information I have in front of me here, would be y equals the slope, rise over run, times the absolute value of x, minus my h value, which is a 3, plus my k value, which is a negative 2. Plus a negative 2 is just a negative 2. Okay? You'll be able to do exactly the same thing here with the absolute value. There's your h and k right here. 2, 3. 2, 3 is my h and k. And then you, instead of rising, you're dropping. Drop 1, 2, and run 1. So you'd be able to find your slope of drop 2, run 1. Okay? You'll be able to do the same thing. Then we can move on to exponentials. We talked about parabolas, lines, absolute values. Now let's move on to exponentials. Exponentials are kind of tricky a little bit, but we talked about it before. We always have y equals a certain number, we call it the base, to an x power. And that is the simple parent function. Sometimes they are translated, so we have the h affecting the x and a k value. Okay, this h and k also not only shows the translation shifted, it also shows our asymptote. So the asymptote is our y equals k value. Okay, that's our asymptote value right here. So I look at this function and I see it is coming close to, but is not going to touch y equals 1 line right here. Okay, and right directly below it, I would see my my h and k value. It's working backwards from graphing. When we were graphing an exponential, we always look at the h and k first, and we came and marked it, our asymptote, and then we graphed the point right above it. Here we're working backwards. We see the point, and we mark the asymptote right below it. So I know that this point 0, 0, 1 is marking my h and k. I already had a feeling that this is shifted up. Now this is telling me for sure that it was shifted up. Okay, so now I know that I'll have y equals b to the x value minus the x value here for h is 0. So I don't need to put minus 0 in here. But my k value, I better make it obvious here, plus 1. Okay? So there's my h, there's my k. It came from the 0, 1. Okay? Then, all I need now is to figure out what the base is. Why don't I use another point here that is obviously given to me? How about 1, 3? 1, 3, I'll use it to solve for my base. That's the only thing I need to solve it. So I'm going to use 3 for y equals the base I'm trying to solve to the x power plus a 1. So I need to get the base by itself, so I'm going to subtract 1 from both sides. 3 minus 1 is a 2, which it will equal my base to the x power. But remember, the x power is 1, so this should be a 1. So what number to the first power equals 2? Any number to the first power equals itself. So 2, this base must equals 2, okay? Because that's the only number to the first power that will equal 2, must be a 2. So now we have our base. We already figured out that there is a shift up, a vertical shift, moving the function upward. So now we know that our final function is y equals 2 to the x plus a 1. And we can go ahead and write that here in the worksheet, okay? So it would be y equals 2 to the x plus 1. With exponential functions, I always get scared and I like to double check my own work. So the asymptote here is y equals 1, yep. And the h value is 0 and the k value is 1, yep, there it is. I would graph the point right above it, there we go. And if I use the base of 2 from here, up 1, 2 over 1, I would get 1, 3. So I checked that this equation fits all the criteria of an exponential, okay? And that's one of the most difficult functions to come up with the equation. So you have to kind of like work back and forth until you make sure that everything is correct, okay? All right, let's keep moving on. There's a lot of review questions here. And if I'm going to keep on recording this video until my flash drive is completely full. Okay. All right. So now we're going to graph the given equation and state the domain and range, and it tells me it is giving me the domain and range must be given in inequality notation. I have no choice. It's inequality notation. Okay. All right. So take a look at this function right here. If I had an x squared, it would be a parabola, but I don't. If I have an absolute value, bars, it would be an absolute value, but I don't. And I don't have x as an exponent, so this is not exponential either. This is a line, okay? This is the equation of a line. I just have to isolate my y. I have to get everything away, peeled away, so I can get y by itself. So I'm going to add x to both sides. I would have 2y equals x plus 0, okay? The 0 is there, I added an x. I know that equations of line needs to be more in the shape of y equals mx plus b, so I'm almost there. If I divided by 2 here, divided this one by 2, and divided this one by 2, I would have y by itself, because this becomes a 1. X divided by 2 is the same as 1/2 x, and 0 divided by 2 is just 0. So I just manipulated with order of operations here. I manipulated this equation to be in this form, and now I can see clearly that the y-intercept is 0 and the slope is up 1, run 2. So here we go, 0, my y-intercept. Up 1, run 2 is my next point. I can keep on going, up 1, run 2. That's enough for me to go ahead and graph this line. And roughly, sorry, it's really crooked. Should have been better than that. Here we go. There's my line, and it asks us, give me the domain and range in inequality notation. So it looks like this is a line, and it's going to go on forever in the positive axis to the negative axis, to the positive y-axis, to the negative y-axis here. In all directions, it's going to go forever. All the x values is going to be part of my function. All the y values are going to be part of my function. So the domain are all real numbers. You can just write that, all real numbers. And the range is also all real numbers. I teach my students that they can just give me the symbol for all real numbers, which is just double leg R, double leg R. This is another option for it. It means the same thing, okay? All real numbers. This case 11 is extremely similar to case number 2 over here, 12. You'll be able to do it, okay? All right, now let's identify what kind of function do we have here. I have a squared. When I have an exponent of 2, I know this is a parabola, okay? So I take a look at my vertex right here and right here. This is my h value, this is my k value. Opposite of h, same as k. So my vertex is 1, 2. That's where I'm going to start from. So come over here, 1, 2, right here. I went 1 on the x, up 2 on the y. So that's my vertex right there. I look at this leading coefficient value and I see that's negative. My parabola is opening down. Let me remind myself right here. And I have a negative a half. That means I'm only going to drop half of a unit. And I'm going to move it to the right and then to the left because parabolas are symmetrical. So I don't count drop 1, run 2. This is not a linear, this is not a slope. So I just count drop a half to the right and to the left. And here's roughly what my parabola looks like. Okay? In arrows in all directions. This is going to positive infinity in the x-axis, negative infinity in the x-axis. It looks like I'm going to be going down here forever, negative infinity here in the y-axis. I'm sorry, yeah, in the y-axis, and positive infinity up here. It looks like it's cut right here. This is the highest value I'm going to ever get on this parabola. Okay? So in the x-axis, it looks like I'm going to get all of the x values to be part of my parabola. I can go all the way here. If I trace it down, I will find a value that touches my graph. So my domain, again, are all real numbers. I'm just going to use the symbol for all real numbers. But my range is going to be only the y values that are less than 2. Y values that are less than 2. But it's closed here, so it equals 2 as well. So less or equal to 2. Okay? So notice I found the vertex. I found the general shape of it, so I have an idea that is a pointing down parabola. I use that negative a half to just drop a half in both directions. And then I observe my domain goes on forever. Forever and ever in both directions, positive and negative infinity. My range starts here at my vertex, but is coming down forever. Okay, so all of my range right here, forever. Okay, to negative infinity. This is also a parabola because I have a squared, an exponent of 2. You might not see the h, but the h is there. I can rewrite this function without changing the values or the meaning. 2 times x minus 0 squared minus a 3. I just put in a minus 0 for x, did not change the value or this statement at all. And you can see that here's your h and here's your k, opposite, same. And there's your stretch that you can use it one time. Okay, and you'll be able to graph this one. Okay, let's see what we have here. My linear absolute values, they are just as easy as 1, 2, 3. Here we go. Opposite to what we do to x, same as what we do outside here. There's nothing out here, so it must be a 0. So my starting point, I'm going to write SP for starting point, or vertex if you want to call it vertex, is -4, comma 0. So -1, -2, -3, -4, comma 0. Here's my starting point. Now let's stop and let's take a look at it. We have an absolute value function, the V-shaped ones, okay? There's a little V shape. And I have to look at this positive number in the front here. Okay, so I made a mistake already, I can see. I didn't realize it until I started. There's a 2 minus my absolute value. This 2 is my K value. My K value should not be in the front. My K value should be in the back. So I'm going to subtract, I'm going to rewrite it. It's not subtracting. So I'm going to admit here I made a big mistake here already without looking at my function. So my 2 should be in the back here. I'm going to rewrite my function as -1 times my absolute value of x plus 4, and the 2 should be in the back. Now it's written in the right form. And that's one of the tricks that students fall for it, and apparently teachers fall for it as well. My 2 should not be in the front, it should be in the back. Okay? So now I can go ahead and start all over again. Opposite, same. And that's my starting point. It will be -4, comma 2. So -4 up to 1, 2, right here. So let's forget this guy over here. If I had a white out, I would get that out. Okay? That's my starting point. Now I come back to my absolute value, and I look at this -1 in here, and that is my rise over run or drop and run for my linear absolute value. So I just need to drop 1, run 1 to each of the sides, because absolute value is also symmetrical. And there goes my absolute value. Okay? So in absolute value, we apparently, okay, I fell for the mistake. First, make sure that it's in the right form. Okay? You should not have a number here in the front. That is your K value should be in the back. It's okay to have a negative or a positive number multiplying the absolute value, but not a number in the front of it. Okay? So if you take a look at number 16, let's check to see if it's in the right form. It is okay to be a multiplication, but it's not okay to be an addition or subtraction here. So that's why I moved my 2 to the back. So this is 2 times my absolute value, and there's my K value that is in the back. That's exactly where it should be. There is no H value, so my starting point is going to be 0 for H, and my K is 1. And there's my slope of rise 2, run 1. Because it's linear absolute value, there's my 2. I can go to 0, comma 1 for y, right there. And use my slope of rise 2, run 1. Both sides, because absolute values are also symmetrical. Okay? Let me double check that I didn't make any mistakes. There's no H value, so that's 0. And my K value is the same, it's 1. And 2 times is okay, so that's my slope because it's m times the absolute value. Okay? So we've got to be very, very careful with this, paying attention to slope and starting points. Here's an exponential. Okay? I'll do an exponential, you'll be able to do the other one. Okay, the exponential. The first thing we want to know is the asymptote. Okay, so there's an opposite to what we do to the x value, same as what we do out here. So this is going to mark our asymptote. Asymptote. Okay, so it looks like we have opposite of -1 is 1, same as 0 over here. So at 1, 0, right here, we have an open circle. And it marks our asymptote right here at y equals 0. Okay, so y equals 0 is our asymptote line right here. I am not touching this line. Okay, the point right above it, it will be part of my graph. I guarantee you, if you plug in a 1 right now in this equation right here, 1